Hello friends, when you're adding capacitors that are in series, there's a special way that you have to do that. And here is the derivation for the formula of adding capacitors in series. In the end, what you have to do is take the reciprocals of the capacitances, add that, and then take the reciprocal again, the flip-add-flip rule. So here's a circuit where there's a battery and there are two capacitors of capacitance C1 and C2. We're not going to put numbers in here because we're looking for a general formula. So we do everything in terms of the letters Q and C and V. Our equation that relates capacitance and charge and voltage is Q equals CV. And we can write this for each of the capacitors. So Q1 is the charge on capacitor 1 is C1 times V1, and Q2 is C2 times V2. Okay. And what we know is that the voltages have to add up. So VBAT, the total voltage, gets distributed between the two capacitors. And so VBAT, this is by the loop rule, the voltage of the battery has to be equal to the voltage on capacitor 1 plus the voltage on capacitor 2. Okay. Now, the thing that we know also, because the capacitors are in series, is that they have the same charge on them. When we get to circuits where there are resistors, and when resistors are in series, they'll have the same current because it's the same flow of charge. The idea here is conservation of charge. So whatever charge collects on capacitor 1 also has to collect on capacitor 2. And so Q, let's call it Q total, is equal to Q1, which is equal to Q2. Okay. Another thing to add here is that we have Q equals CV. So Q total is equal to C total times V bat, which is kind of the total voltage. Okay, so now what we're going to do is we're going to take this equation, but we're going to substitute in our other equation. So here, so V bat from this equation, V bat is equal to Q total over C total. And V1 equals Q1 over C1. And V2 is Q2 over C2. So I've got an expression now for the voltage on each of the capacitors. And now I'm going to substitute these into this equation. And I'm going to get this thing over here. So instead of VBAT, I write Q total over C total. So that's the equivalent capacitance equals. So instead of V1, I write Q1 over C1 plus Q2 over C2. Great. Now, the thing is, all the Q's are equal to each other. Q total equals Q1 equals Q2 equals Q. So I can just rewrite this equation now. Q over C total equals Q1 over C1. Sorry, just Q over C1. And that's equal to Q, sorry, not equal, plus Q over C2. Notice now all the Q's cancel out. I can divide everything by Q. And this becomes 1 over C total equals 1 over C1 plus 1 over C2. And so that's the formula now. When I have capacitors that are in series, the way that I find the equivalent capacitance or the total resistance is I do what I call the flip-add-flip rule. You have to add up the reciprocals and then take the reciprocal of that. I hope that was helpful. Thanks for watching. Don't forget to like and subscribe.